So you can look at each of these derivatives is kind of like it's a shorthand way of thinking what would happen if I did one more object. So what would it cost me to make one more object? How much revenue would I expect to gain or lose from selling one more object? Remember, you would lose revenue from selling another object because you would have to lower the price on all of them in order to sell that object in the first place, right? Profit is the same idea. Would I gain or lose money, right, from selling one more unit? Right? Because of course it is possible to sell too many, right? In the sense that you have to lower your price so much in order to sell that number. Let's try a full question here, and then you can. There's an assignment on this one, and there's lots of ways you can practice it. So let's try this one. It says a music store sells an average of 120 CDs per week at $24 a piece. A survey suggests that every 75-cent decrease in price will have 5 more CDs sold. Yeah, I mean, never mind the fact that what was the last store that sold any CDs, but I guess we should update this. Let's think about what we know about the demand function. The demand function is a straight line. We know this because the revenue function is x times p of x, and we know the revenue function is a quadratic. So a regular x times a linear is going to give you a quadratic. Let's think about what we know about the demand function. We know that p of 120 is 24. We know that p of 125 is 2325, right? And let's just think through how we did this again. This is like saying to sell 120 CDs, I should charge $24. Here it's like saying to sell 125 CDs, I should charge $23.25, right? I need to take off 75 cents from the price in order for this to work. Now, write this out in mx plus b form. 24 equals 120m plus b. 2325 equals 125m plus b, and subtract the two. Okay, we subtract the two. We get 75 cents is equal to negative 5m, and therefore, what is that, 3 over 4, so negative 3 over 20 is equal to m, right? And this would be the idea that sorry, that's totally wrong. No, sorry, that would be like to sell. Yeah, right. So to sell 20 more CDs, I would have to drop my price by $3, right? Basically, is what that's saying. It's just the lowest it's the lowest, the reduced fraction. Okay, so now let's put this in. We go 24 equals 120m plus b. 24 equals 120 times negative 3 over 20 plus b. 24 is equal to negative 18 plus b, and therefore 42 equals b. Now, I'm going to leave this to you as a thinking question. What does b mean? Is there like a does it have a meaning in the sense of does it correspond to something in the question? I'm going to leave that with you. Okay, so anyway, we have our equation now. P of x is negative 3 over 20x plus 42. And this tells us what price you would charge, or excuse me, in order to get, however many sales you want. The revenue function is easy. Take the same thing, you add an x there, and you add an x there. Okay? And now we have our revenue. So it says determine the price function. Okay, so I actually didn't need to do that. So the price function is right here. So there's the answer to that one. Okay, so there's the answer. Now it says determine the marginal revenue if you sell 150 CDs per week. Okay, so let's write our revenue function again. Our marginal revenue function is to just take this and do the derivative. So we get negative 3 over 10 instead of 3 over 20 because the 2 comes down in front, plus 42. R prime of 150 is therefore equal to negative 3 over 10 times 150 plus 42. R prime of 150 equals negative 45 plus 42, right? Because it would be 15 times 3. And then R prime of 150 is equal to negative 3. And then again, because it's a derivative, we want to make sure we express it as a unit. Revenue is dollars, and the X is being measured in sales. So you could say negative $3 per sale or negative $3 per unit, right? Whatever is fine. Okay, remember to include your rate of change. Let's say or negative $3 per unit or negative $3 per sale. Either one is fine. Okay, now what does this mean? Explain the significance of this value. Okay, this means that in order to sell one more unit, I will be losing $3 of revenue. Of course, I'm not losing money on that one sale. The idea is I would have to lower my price in order to sell that extra unit, and overall I would lose more money from lowering my price on all my sales than I would make from selling one extra sale. Okay, so basically another way of interpreting this is this company is selling too much and should lower their price to sell fewer items but make more revenue overall. Okay, that would be my advice or my interpretation of what's going on for this company. Now, it says the cost of producing or acquiring the CDs is given by this equation. Now again, the cost is normally something that's just given to you, so you don't really need to develop it. It's just something given. So we go 3,000 plus 4.2x minus 0.003x squared. We get C prime, which is the marginal cost. It would be 4.2 minus 0.006x, right? And the marginal cost of producing 150 CDs. So C prime of 150 would be 4.2 minus 0.006 times 150, and that is 4.2 minus 9, 0.9, I'm guessing. Okay, so we get C prime of 150 is equal to 3.3, and again, dollars per unit. Okay, so basically the marginal cost of producing 150 CDs is of $3. Your cost is rising at about $3.30 per unit. So again, a shorthand is like the cost of producing a new CD when you're already making 150 CDs is approximately $3.30. Okay, so that's a way of interpreting what this means. Now, here it's asking how much does the actual CD cost? So, and we're going to compare this to the marginal cost. So, what we're going to do here is we're going to go C of 151 minus C of 150. So here we're not taking any derivatives. We're just actually analyzing the cost of that actual CD. So let's just write the thing out again. 3,000 plus 4.2x minus 0.003x squared was our cost function. And if you make 150 CDs, it's going to cost you $3,562.50. And if you make 151 CDs, it's going to cost you $3,565.80. Sorry, I put these in the wrong order. And we find that these two, when you subtract them, is $3.30, right? So the 151st CD costs $3.30 to make if you've already made the first 150 of them, right? So we get the same answer. I'm just a bit suspicious of that, so let me just double check the work I did before. Derivative C prime of 150. Yeah, okay, so they're just the same. 151 minus C of 150. Yeah. Oh yeah, okay, there you go. So that's because I was rounding. So let's round it to if you find actually the price is slightly different. So let me just make a quick adjustment to this. So not 0.5 but 0.797. And then you actually get the answer is 297. Now of course it still rounds to approximately 330. Let's just say approximately $3.30, right? So it's I just wanted to say that they are slightly different. You should expect them to be slightly different, but they should be very close together, and they will often round to just be the same value. Okay, determine the marginal profit from the weekly sales of 150 music CDs. Okay, so the profit function, right? We go back to our revenue function way back up here. Negative 3 over 20x squared plus 42x. So again, Rx minus Cx, Px is equal to negative 3 over 20 x squared plus 42x, right? That was our revenue. And then our cost, again, is just make sure you use a bracket here so you don't mess this up. 3,000 plus 4.2x minus 0.003x squared. Okay, so we should collect some like terms and expand out that bracket. We get negative 3 over 20 x squared plus 42x minus 3,000 minus 4.2x plus 0.003 x squared. Again, I'll just convert these into fractions. So we get negative 3 over 20 x squared. Oops. Plus what would that be? 3 over 1,000 x squared. Then we have 42 take away 4.2, so that's 37.8 x minus 3,000. So to combine these together, you get P of x is equal to, okay, so we'd have to multiply that by 50, so negative 150, so negative 147 over 1,000 x squared plus 37.8x minus 3,000. Okay, so that's what I get from my profit function. Now, just to make sure I didn't screw this up, let's just write it out. So revenue is negative 3 over 20 times x squared plus 42x, and Rx minus Cx, and then simplify. So we get negative 147, and then I think that other number, 37.8, is the 187 over 9. So 37 minus 189 over 5. Yeah, okay, good. So that's right.